So I know you guys, and I know you guys like doing wild things with Proxmox. Not naming any names here, but I know at least one of you has tried to do integrated GPU pass-through from your host to a virtual machine. And when you do that, you know that you no longer have a display output on the virtual machine, which makes it really hard when the kernel panics to debug what happened. Some of you guys are also probably playing with some relatively experimental drivers, VFIO, things like that, and I don't blame you for getting frustrated when the kernel panics. So today, I'm going to show you how to get those kernel panic logs sent over to another system to help you debug your workflow. So if this sounds like a problem you're having, come along on this adventure. Just for a little background here, I've got a Linux system. If I run dmessage, we can see we get the output of the kernel message buffer. So these are all of the kernel logs for the low-level stuff. So if we look for something like, I don't know, Ethernet. So often if you're dealing with drivers print their information to the kprintf function, which goes into dmessage, the kernel message buffer. So these messages are relatively important. If you've ever been working on your system and seen random system messages just kind of pop up on the screen, those are relatively important kernel messages. So that's the buffer we're talking about here, the kernel message buffer. This is not the systemd journal, which deals with service logs. This is specifically the kernel log. So if we go over here, we can see all the way back in 2001, Linux thought it would be a good idea to send these messages over UDP so they could debug the problem. And of course, I've written a guide on my website that you can help copy from, specifically for Debian and Proxmox. So here's the basic gist of how this works. In the kernel, drivers print messages. It's called print K. When a print K happens, it usually goes in the message log. It might also get written to disk, things like that happen. It can go out to the serial port if you have a serial port, and it can send a UDP packet. This UDP packet will contain the text of the log, and that's basically it. So if we have some other device in the network that can capture these UDP packets that are just flying around, we can reconstruct the kernel log from all of those. Now, the kernel is not running this through the normal TCP/IP UDP routing stack. It's basically doing this directly to the Ethernet adapter and sending a packet straight to the TX buffer. So this happens early in the boot process, before we've set up routes, before we've gotten an IP address, before all that fun stuff has happened. And we're going to use the broadcast MAC, so everyone on the network is going to see our UDP packets. And we're going to use port 6666 as the default. So if we just want to do it right now, if we're doing something dangerous and we want to start the log, it's pretty easy. We just have to mod probe the Netconsole module. And so there's a whole syntax here, which if you want to follow the link, you can look it up. But basically we need @ / and then the name of the Ethernet interface, comma @ destination address, and then /. And that'll use all the defaults. And here we can use real addresses because we're already set up with networking and stuff like that. And we can also use the real name of the interface because that's what it's currently named. So I've got two systems here which we're going to work with. So one is called crashes, that's the one we're going to crash. And the other is called netcat, so we're going to capture on. So if I get the IP address of netcat, it's this 2601 thing. So we'll need that. So we'll copy this guy, paste him. And then we need to backspace just where the IP address goes. Copy the destination address and paste him in. It's a frustrating thing about the serial console. Sometimes we lose stuff. So there we go. That's what it should look like. So these are the actual messages from print K. So netcon is in our dmessage now. So if I do dmessage netcon, so you can see got my errors from earlier. And then, so it's going to use local IP address on ETH0, port 6666. Destination address is that guy on port FFFFFFFF. And then if we just want to listen to it, we can use netcat. So I just got the command for that. So here and paste that in. So now I'm going to cause a kernel panic. So I didn't cause a kernel panic, but I caused it to have a whole bunch of debug information. And if I come over here, look, we got all that debug information. Just appeared on our console here. So if you're doing something dangerous, loading a driver, something that it crashes right away, this might be a pretty good way to tell what's going on from the logs. However, if you needed to start at boot, or you want to log continuously, there's some more advanced things we can do to make it start at boot, or to make our logging server log for a long period of time. So let's get on with those two. So in order to log at boot, we need to edit the kernel command line. So on this system, it's an etc default grub. Now some Proxmox systems use a different path for this, and I put that in the blog too. But in this case, it's called grub command line Linux, and we're just going to edit this to add some arguments on the end. So netconsole equals, and then the same thing as before, at eth0 at blah blah. So at /eth0, comma, at. So earlier when we mod probed the module, we could just give it any old IP address, it would figure it out. At that point, networking is up and running, the interface is named eth0 because UDEV has renamed it, all things are good. But early in the boot process, this is not true. So IP addresses haven't been set up yet. MAC addresses have, so we can rely on those. Ethernet adapters haven't been renamed yet from whatever the boot name was, so we got to figure out what the boot name was. And basically our only option for an IP address is to either tell the kernel what its IP address is in the kernel command line, or to use an IPv6 link local. And then it'll generate its own link local from the MAC address. So I need to figure out what eth0 was, and I need the link local address of my destination server. So the link local address is easy. It's my FE80, in this case it's that guy. So I'll just copy that one right in. I need a slash on the end. So I'll save that for now. And then let's look at dmessage to see what eth0 was. So I'm going to dmessage, I'm going to search for eth0. So in this case, it looks like I lost the logs that are that old, so I'll have to reboot so that it comes up again. There we go. So kernel renamed ENS18 from eth0 and then back. So ENS18 is what we need. So come over here. Instead of eth0, we're going to do ENS18 and the FE80. So now that that's done, we can update grub. And again, if you're using Proxmox boot tool, you use Proxmox boot tool instead. If you're doing system deboot on Proxmox, Proxmox systems are like 50-50 split if you're using grub or system deboot, but both of those instructions are in the blog post. So update grub ran, let's reboot and see how it works. So let's see, so it looks like Netconsole set up. So the command we gave it was at /ENS18, comma at FE80 slash. So it used local port 6665, local v6 address, interface ENS18, remote port 666, and remote address FE80, and remote MAC broadcast. So it says device ENS18 is not up, so it brought it up, and it used the local IPv6 address, which it calculated from its own MAC address. And so netcon is enabled. So I'm going to go over here to my logging system and run netcat again. So I'm just logging UDP on port 666. Then I'm going to go over here and I'm going to restart the system. So it's going to go down, it's going to come up. And so we can see there it is starting to go down. And then we should see it come back up in this log. Oh, there it goes. Yeah, so it looks like our first log is, so right here we get log at 00. So it prints the early messages as soon as it can, and then it catches up. So right now we've printed all this early kernel stuff, and we're down here, and the system's running. So what if I crash the system now? So sysrec trigger, I can force a crash. So if we give it a C, we'll do crash. And then we'll get a kernel panic. So now the system is locked up. I can't do anything. But over here, we got it. So we had some logs at 3 seconds as the system booted up. We had all this stuff as the system came up. And then we got call trace. So panic happened there. We can follow it down. Yeah. So if your headless system is crashing because you're doing wild stuff, maybe this will be able to give you more information than nothing. But we still have to figure out how to save this somewhere. So I'm just going to write a simple systemd script that just runs netcat. Then that systemd unit will end up with a journal entry in the journal. We can look at it. So I have the syntax here. It's pretty easy. So we're going to put it here as netconsole log.service. Oops. I'll paste in the service. So all it's going to do is it's going to exec netcat just like we were doing. And that'll just log the output of the service into the journal. So I'll paste that in. We'll reload. And then, so journal control XCU netconsole log will tell us what's going on. So currently nothing has happened. So the system crashed, I got to restart it. There we go, so it's coming up. So if I look at the journal log again, you can see here's the logs we've gotten so far, and we can scroll through them with systemd journal. And if I want to look at them again, I can just hit quit and then start again. That's about where we are. So now I can crash the system again. So we're going to do, should I do a T or a C? We'll do a C. We'll just crash it again. And so we're still looking at the historic logs, but if I quit and reopen the journal, you can see we have the kernel panic there, and we can look at all of it. So now, this isn't something you should be enabling all the time. It's sending packets to the broadcast MAC address. So even though we're sending packets to an IPv6 link local address, they're not going to the specific MAC, they're going to everyone. So anyone on the network can run Wireshark and look at all your packets just in the clear, your whole kernel log, which is not the best thing in the world. If you're on a LAN and you're debugging, it's obviously part of the debugging process, but you should probably turn it off if you're not using it. So basically just reverse the kernel command line, back it out, and if you're running with modprobe, you just rm mod. Again, the blog has the command for that. So hopefully, since you guys like doing wild stuff, this has helped you guys. If you found it helpful, I have a Ko-fi down below. You can tip me. If you want to chat with me more on Discord, I've linked to that as well. Like and subscribe, all that good stuff, and I'll see you guys on the next adventure.